Okay, so we're moving on to trigonometry now, which is going to be chapter 4. And 4.1 is going to be pretty much a review of the trigonometry that you learned in geometry. So it starts out by telling you the trigonometry functions that we have. And in this case, they referred to this angle here as theta. So that's theta. So we have 6 trig functions. The 6 trig functions we have are sine, cosine, and tangent. And their reciprocals are for sine is cosecant, cosine is secant, and tangent is cotangent. And what they mean by reciprocal is that it's going to be the ratio of opposite and hypotenuse, but in a different order. Here, the ratio of adjacent and hypotenuse, but in a different order. Just flip them, and opposite adjacent, different order. Okay? So they gave you an example. In this case, they picked this angle to be the angle you're going to work from. So if this is what you call theta, then across from theta would be the opposite side. The hypotenuse is always the side across from the 90-degree angle, and the one left over is adjacent. So let's take a look at an example. It says find the exact values of the 6 trig functions of theta. So in example 1a, first of all, you should already list out the 6 trig functions. So I'm going to write down here sine, cosine. Okay. So sine theta, cosine theta, tangent theta, and then the reciprocals, which are going to be, people get confused. They think that sine, the reciprocal should be secant because they both start with S, but it's not. The reciprocal of sine is cosecant, and it can be abbreviated this way, cosecant theta. The reciprocal of cosine should be secant, secant theta. And for tangent theta, the reciprocal is cotangent theta. So now it's just a matter of finding out what the opposite, adjacent, and the hypotenuse sides are. So if theta is here, this is opposite. Across from the 90-degree angle is the hypotenuse, and what's left over is adjacent. So now I can say that sine theta should be opposite, which is 5 over hypotenuse, which is 13. Cosine theta should be adjacent, which is the 12. So the side that measures 12 over the hypotenuse, so 12 over 13. And the tangent should be opposite over adjacent, so 5 over 12. And then you just flip them. So cosecant theta is 13 over 5, secant theta is 13 over 12, and cotangent theta is 12 over 5. So that's for that triangle. If we move on to the next example, example 1b, I am going to once list the trig functions, sine, cosine, tangent, and then I need to do cosecant. I always write theta, so I specify which angle you're talking about. Secant, cotangent. Okay, so in this case, theta is over here. So from that angle's perspective, that would be on my opposite side Across from the 90-degree angle is the hypotenuse, and the leftover is adjacent. So sine theta should be 21 over 29. Cosine theta should be 20 over 29. And finally, tangent theta should be 21 over 20, opposite over adjacent. Flip them, 29 over 21, you get 29 over 20, this should be a 20. And cotangent theta should be 20 over 21. So this is pretty simple. We're going to move on. Next example, it says use one trig value to find others. So what I'm going to do in this example here, I am going to draw a triangle. It has to be a right triangle because we're only talking about right triangles in this section. So I am going to draw a picture of a triangle. I know that tangent is opposite over adjacent. So in my triangle, if I'm going to call this theta, and this is the right angle. And the side opposite to theta should measure 1. So I'm going to say that across from theta is 1 and adjacent to theta is 2. Now, you should remember that you can find the third side of a right triangle by using Pythagorean theorem. So to find this side here, I can say that x squared has to be equal to 1 squared plus 2 squared, which means x has to be square root of 5. Okay? So now I can go on and I can say that this side here, the hypotenuse, is square root of 5. And now I can write all the other 5 remaining trig functions. So I am going to write here, I already have tangent, so sine theta, cosine theta. And then I'm going to do cosecant theta, and I am going to do secant theta, and I am going to do cotangent theta, because I already have tangent theta. So sine theta should be opposite over hypotenuse, so it's 1 over square root of 5, but you have to rationalize. We'll get to that. Cosine theta should be adjacent over hypotenuse, so 2 over square root of 5. And cotangent theta should just flip 2 over 1 or just 2. Oops. Now, for cosecant theta, I'm just going to flip that, so square root of 5 over 1, which is just square root of 5. And secant theta should be square root of 5 over 2, just flipping. Now, just keep in mind that for sine theta, if you have 1 over square root of 5, the general rule is that you should not have a radical in the denominator, so you have to do something called rationalize, which means in this case you need to multiply top and bottom by radical 5. And 1 times radical 5 is radical 5. And the bottom, radical 5 times radical 5, square root signs cancel out and they're just left with a 5. So you should be able to rewrite that as square root of 5 over 5. This one, when you rationalize, you get 2 square root of 5 over 5. Okay? So that would be number 2. Moving on. Okay. This is very, very, very important concept This is going to give us the basis for all the trig that is going to follow. In geometry, you should have learned about special right triangles. There are two kinds, a 30, 60, 90 triangle and a 45, 45, 90 triangle. And at some point, you should have learned that the ratio of the sides in a 30, 60, 60, 90 triangle is always the long leg is going to be the short leg times the square root of 3. And the hypotenuse is always 2 times the short leg, so 2x. 45, 45, 90, the two legs are the same, so they're both x. The hypotenuse is always the short leg times the square root of 2. So here this table summarizes all the trig values for 30-degree angle, 45-degree angle, and 60-degree angle. Okay? So if we're talking about the 30-degree angle, we're talking about this one over here. In a 30-degree angle, sine is going to be opposite, which if you replace 1 for x, that's just a 1. This would be just a 2. This would be just radical 3. So if you're talking sine theta, in this case, it would be 1 over the hypotenuse, which is 2. So 1/2. Cosine 30 would be adjacent over hypotenuse. So square root of 3 over square root of 3 over 2. Tangent of a 30-degree angles would be opposite over hypotenuse. So it's just one opposite over hypotenuse. No, tangent opposite over adjacent. Sorry. So for tangent opposite over adjacent, for this one, it's gonna be, it'd be 1 over radical 3, but when you rationalize, you get radical 3 over 3. Cosecant, then you just flip them, and then for 40, 45, 45, 90, it doesn't matter if you call this one theta or that one theta, because they have the same measure. So once again, these are rationalized. So sine and cosine 45 would be 1 over square root of 2, and then you rationalize and get that. Okay, these values will come back over and over and over again. So become familiar with them. And you will have, at some point, to have them memorized. You need to memorize them. Okay. And then this really is going to feel like geometry again. When you need to find a missing side in a right triangle and you have an angle on a side. In this case, you have this angle, you're looking for this side. So you need to establish what that side is from the 53-degree angle perspective, and this is opposite, and they're trying to find the hypotenuse. So you need to write the trig equation, which in this case would look like this. You'd say, because you're looking for the hypotenuse and you have the opposite, if you remember from geometry, you're so katoa. So in this case, I have O and H. I have this two. So you're going to have to use sine. So sine of the angle, you always have to list the angle, 53 degrees, is going to be equal to opposite, which is 15, over hypotenuse, which is x. So now you'd cross multiply, and you'd say that x times sine 53 is equal to 15. So then you divide both sides by sine 53, and you'd get this answer over here. You'd put that on the calculator. Now when you enter this on the calculator, make sure you are in degrees. So 18.8. and its units. Okay. Then this is the second example, 3b. So in this case, I will follow the same procedure. This is the angle, this is opposite, this is adjacent. So now I am going to say that tangent 21 is equal to opposite, which is 9, over adjacent, which is x. And for this one, I'm going to use a shortcut. You can cross multiply just like we did before. Or I tell my geometry students that if the variable here is in the denominator, you're going to have to divide. Do this divided by that, divided by tangent 21. If the variable is in the numerator, you just cross multiply. So in this case, x is going to be equal to 9 divided by tangent 21, which should give you 23.4. Okay? All right, I believe for this section, this is it. Oh no, okay, yes, this is when you want to find an angle. So we're not done, we're almost done. Angle of elevation and depression, and solving a right triangle. Okay. All right, so for this, it says when a trig value of an acute angle is known, the corresponding inverse trig function can be used to find the measure of the angle. So if you look on a calculator, if it is a TI-34, then you will see a list of sine, cosine, tangent, then sine -1, cosine -1, tangent -1. So those are the inverse sections. For the 84, you have a key for each. But here, this is the inverse of sine. This is the inverse of cosine. And this is the inverse of tangent. So what this means is that if you know the measure of two sides, you can find out the measure of the angle by using inverse trig. Essentially, it goes like this. If you're looking for a missing side, you're just going to use sine, cosine, tangent. If you're looking for a missing angle, then you need to use inverse sine, inverse cosine, inverse tangent. Okay? So let's look at some examples. Over here, they want you to find the angle. So I am going to use inverse sine or cosine or tangent. So the angle is over here. I know that's going to be the opposite side. And this is the hypotenuse. So now I can say opposite and hypotenuse, so 14, so sine. I'm going to say that sine theta is equal to opposite, which is 14, over the hypotenuse, which is 16. So at this point, because I'm looking for the angle, I would write sine inverse sine of 14 over 16. And that should be my 61-degree angle. Okay? Now, you can simplify the fraction or not. It doesn't matter. 5b, here's the angle. So this side here is adjacent. This side here is the hypotenuse across from the right angle. So I'm going to use cosine. So cosine theta is equal to 5 over 12. Then once again, I'm looking for the angle. So use inverse trig, cosine -1, 5 over 12. And that should give you about 65 degrees. Okay? Okay. Once again, you probably learned this in geometry. This should be a review. They're talking about angle of elevation and angle of depression. The angle of elevation is always formed by the observer's eyesight to the object. So this would be an angle of elevation. The angle of depression is always the horizontal line and the object looking down. So this would be the angle of depression. People make a lot of mistakes with the angle of depression because they think that it should be this one, but this is not the angle of depression, okay? In the end, these two are going to be the same measure because they're alternating triangles, okay? So, example 6 says camping. A group of hikers on camping trip climb to the top of 1,500-foot mountain. When the hikers look down at an angle of depression of 36, they can see the campsite in the distance. What is the horizontal distance between the campsite and the group to the nearest foot? So the picture makes this very easy. You can either look at this as the same height as that and say this is 1,500 feet, and this would be x feet, or you can say that this angle is 36 degrees because those two are alternating triangles. So at this point, it's just a matter of setting up the trig equation. So I am going to say, let's see, that's the angle opposite. This is opposite to the angle across. This is right angle, right angle. And the x is adjacent. So now I can say tangent 36 is equal to the opposite side, which is 1,500 over x. Now, you know that this is in the denominator now, so I'm going to do x is equal to 1,500 divided by 1036. And in this case, I am going to use just regular trig because I'm looking for the side. So when you solve for this, you should get this answer, which is 2065 feet. So about 2065 feet. That's for angle of elevation and depression. Okay. And the last thing we need to cover is how to solve a right triangle. And what that means is you need to find all the measure for all three sides and all three angles. That's what solving a right triangle means. So in this case here, you can find this side by using Pythagorean theorem because you have two sides. You're missing one side. So you can say that 37 squared is equal to 20 squared plus c squared. And then once you solve for that, you get the value of c. And then you can find one of the angles. So let's say I want to find the measure of angle A. So if I want to find the measure of angle A, I can use these two sides. That's opposite. This is hypotenuse. So I can say that sine of angle A is equal to opposite, which is 20 over 37. And because I'm looking for an angle on the calculator, I would enter this. And that should give me the measure of angle A, about 33 degrees. And once I have that, then it's very easy because I know this angle here is 90 and the sum of all angles in any triangle is 180. So you can just do 90 minus 33 to find the 57-degree angle. And then I have all three sides and all three angles. Okay, and the last one, last example. So here I have this angle. I can easily find this angle here by doing 90 minus 23, which is 67. So this is 67. And now I need to find sides S and R. So you have different choices now. You don't have to do it the way I'm going to do. I'm going to pick the 23-degree angle, and I'm going to try to find R by using the tangent ratio, because this is opposite to 23 degrees and 35 is adjacent. So I'm going to say that tangent 23 is equal to the opposite side, which is R, over the adjacent side, which is 35. So R should be equal to 35 times tangent 23, and that should be about 14.9. And then I still need to find side S. You can use Pythagorean theorem, or I would use another trig ratio. So I can use 23 again, the 23-degree angle or the 67-degree angle. And I can say that this is adjacent. So I'm going to say that, and this is hypotenuse. So I am going to say use cosine. Cosine 23 is equal to 35 over the hypotenuse, which is S. So S should be equal to 35 divided by cosine 23. And when you solve that, it should be about 38. So S should be about 38. Okay, so I have the three sides, I have the angles, and I'm done. Thank you. Reach out with any questions, as always.